So this is our last homework. We have to differentiate this quotient. Top function prime times the denominator minus the top function times the denominator prime over the denominator squared. The numbers were given to us and we get this. The limit here, we can use L'Hopital's rule, is 0 over 0. So the top function prime is cosine. The bottom function prime is secant squared of 7 theta times the inner function prime, which is 7. It happens that when theta approaches 0, both these are 1. So the answer is 1/7. To differentiate the product, 2 times 1 minus 4z to the first power times the inner function prime times the second function plus the first function times differentiating the square root, 1 over 2 the square root times the inner function prime. The 2 goes away, 2 from the top with the 2 from the bottom. I rearranged 2 times -4. I copied this condensed as possible. I factor out 1 minus 4z from both. So then we have -8 multiplied by the square root, but I also find the least common denominator and I multiply the numerator by the square root of z squared plus 1. So that's how I got -8 times z squared plus 1 plus z distributed here plus, because one of them is out, so z times 1 and z times -4z squared over the denominator. I combine like terms, -8z squared minus 8 and plus z minus 4z squared. 1 minus 4z in front, the denominator, -8 with -4, -12z squared in order, descending order, z minus 8. So I will factor out -1, and also instead of putting the -1 in front, I twisted these two because the -1 will change the signs in here. That's another way. Or you factor out -1 from both, and that's how you get this. Differentiating 2, not e, any number to a function, the answer is 2 to that number, 2 to that function, times the function prime, times natural log 2. Then we were asked to differentiate a quotient raised to the 5th power. So then 5, the quotient to the 4th, and now times the inner function prime. The inner function, the numerator prime is 4y cubed times the denominator minus the numerator times the denominator prime over the denominator squared. I copy the 5 and the quantity to the 4th, and then I rearranged, simplified here, 4y to the 5th plus 4y cubed minus 2y to the 5th minus 2y, and the 4 minus 2 is 2, and then these 2. I realized that the numerator, y to the 4th plus 1, is raised to power 4, but y squared plus 1 to the 4th times y squared plus 1 is y squared plus 1 to the 6th. I factored out from these two, from these three terms, I factored out 2y, and I got 10y, y to the 4th plus 1 to the 4th, and this, and the denominator. In order to differentiate this function, we have the outer, the inner, the innermost, the inner, next inner, and the innermost. So 3 sine squared of the argument times sine prime, which is cosine of the argument, times cosine prime, which is negative sine of the argument, times the inner function prime, which is 2x. Then I collected 2x with minus and 3, and I put -6x in front. I copied, I copied, I copied. We are given a function. We're asked to find the second derivative. So the first function prime is 1 times the second plus the first times the second prime times the inner function prime 2x. So this is copied, and I multiply x by 2x to get 2x squared times g prime of x squared. Now the second derivative. I have to differentiate g of x squared, g prime of x squared times the inner function prime, plus. I leave the 2 outside. I differentiate x squared, 2x times g prime plus x squared, the product rule, the g prime, which is the second derivative of of function g, times the inner function prime, which is 2x. So now I copy this. I distributed 2 times 2x here, and I get this, and then 2 times x squared times 2x. So 2x times x squared is 2x cubed times 2, 4x cubed, g double prime. And then these two are like terms, and then I copy that. That's final. And then two more problems here. Differentiate implicitly. The first function prime times the second one plus the first times the second prime times the inner function prime equals 2x minus 5 times dy over dx. These two terms have to be on one side. This term moves to the other side. And I also factor out dy over dx. So this is negative here. I move it to the other side. It becomes positive, minus 5. And then I divide this by this to get dy over dx. Finally, 2x, this is the product rule, 2 outside. X prime is 1 times y plus x times dy over dx plus 8y times dy over dx. Differentiated 12 is 0. I divided both sides by 2. This is 1. This is also 1. And this is 4. These two go to the other side. These two stay. Or these two go to the other side. It doesn't matter. So I still have x plus 4y and dy factored out. X plus y to the other side become negative. So dy over dx, evaluated when x is 2 and y is 1, after I write negative x plus y over x plus 4y, I get negative 3 over 6, which is negative 1/2. Y minus y1 equals the slope times x minus x1 for the slope, for the equation of the tangent. I replace negative 1/2. I was given the point 2 comma 1, 2 comma 1. I plugged in everything and I got y equals negative 1/2 x plus 2. Thank you.